Why do we need ControlNet for inpainting? There are several inpainting approaches. Are they really that different in quality? I solved 2 challenging inpainting tasks using 4 workflows, plus an extra one with the LoRA, and compared the results. If you want to know the best approach and how to use its workflow, then this video is for you. Yes, I'm using ComfyUI, but I will tell you exactly what to do. You can download the masked images and the workflows, and I've highlighted nodes with important parameters in green. If you don't already have ComfyUI with Flux up and running, watch this video. There will be no cherry picking. You will get the total number of images generated and see both the good and the bad results, and I'll tell you what parameters I used. Now we will start by installing the ComfyUI-Manager to handle custom nodes which might be missing when using the workflows. If it's already installed on your PC, you can skip to the next chapter. So let's install the ComfyUI-Manager. You can find it here on GitHub. Let's scroll down a bit, and here is the installation. Whatever method we choose in order to install the ComfyUI-Manager, we require Git. You can check if you have Git on your PC by typing in a command window git ---- version. As you can see, it's installed on my machine. If you get an error message, then most probable it's not on your machine and we have to install it. So let's just go to this download page. By the way, here is listed exactly what you need. It's a standalone version and these are the options. You can find the required installer packages here. I would suggest for Windows choosing this link. The installation is not very complicated, and as I said, these are the options to choose. Once we are sure to have Git on our machine installed, we can install the ComfyUI-Manager. Although it's possible by just using this BAT file, I would suggest choosing installation method 1. By doing it that way, we stay more flexible, and it's very likely that in the future, for example, for another tutorial, we have to use Git this way too. So let's follow the instructions. First we go to our Comfy folder. There we have a subdirectory ComfyUI. And there is another subfolder, custom nodes. You see, I haven't installed anything there so far, so it's more or less empty. Let's just copy these instructions, paste, return, and now the ComfyManager is installed. Let's simply start or restart Comfy. Now we can start the ComfyUI-Manager by pressing the button Manager. See my versions of ComfyUI and the Manager. If you have older versions, you have to update. This can be done by pressing Update ComfyUI or Update All. If you load one of my workflows and get a screen like this, then some custom nodes are missing. This can be easily fixed with the ComfyUI-Manager. By the way, if you want to try the new UI with the control bar instead of the extra control panel, enter the settings. Scroll down to Use New Workflow and Workflow Management and select top or bottom. Now enter the ComfyUI-Manager and press Install Missing Custom Nodes. You could install the missing nodes one by one, but I find it easier to mark the checkbox of each node and press the Install button at the bottom of the manager. After the installation, you have to restart ComfyUI and reload your browser window. As a final preparation step, we load the Inpainting ControlNet model. All links are in the description. Go on Hugging Face to Ali Mama's page. There you can find the SafeTensors file containing the ControlNet Inpainting model. Currently it has alpha quality. Check the description and pinned comment of this video for updates. Now download the Diffusion PyTorch model SafeTensors file. You have to put it in your Comfy folder in Models ControlNet. I've created an optional Flux subfolder, but it's up to you whether you wanna use it. Anyhow, for better readability, you should rename the saved tenses file. For example, to Flux Alimama Dev ControlNet Inpainting Alpha. Let's start with the first workflow. You can download the files from my Patreon for free. There's no need to pay anything. The link is in the description. If you want to see more videos like this, press the subscribe button. The workflow is a kind of a standard for inpainting. It uses the VAE-Encode for inpainting. In the load model group, you can select the models you want to use. In order to save VRAM, I have connected the GGUF unit loader. If you want to try it yourself, check my video about GGUF. If you don't want to use it, simply connect the normal diffusion model loader. The T5 text encoder is the FP8 version, again to save VRAM. We select a simple prompt to create the word flux with fireflies. Right-click on the source image and open the mask editor. I have already prepared the mask. You can download it from my Patreon too, or simply create it yourself. And then you would have to save to node. This inpainting is quite challenging. It includes text and the background has to be transparent. You could use the load image node for resizing, but in this example we won't do that. By the way, in the workflows I have colored green those nodes in which parameters can be meaningfully changed. Blurring the mask depends on the quality of the mask. The more precise your mask, the smaller the values for the blurring. I would suggest concentrating on the radius if you want to change the blur. This preview image is only for checking the mask. The VAE-Encode is the central node for this workflow. We have to input the image, the VAE model and the mask. I left the grow mask by value at the default. The case sampler is standard. If you found a good seed for a certain prompt, you might want to set it to fixed. Then you can try different values, for example for the mask. The CFG is always 1 because Flux does not know negative prompts. You could try smaller values for denoising, but for me there was no improvement. Finally, the latent image is decoded into a human-readable pixel-based image, but most probably you already know that the image manipulation is more efficient in the latent space, which is why we encode the image into the latent at the beginning of the workflow. I've added the differential diffusion node to the workflow. In the net there is the opinion that it improves inpainting, but if you don't want to use it, you can connect the model directly with the case sampler. In my experience, differential diffusion has an impact on the results and in most cases it's positive. Now we will start the workflow. In order to save time, I have selected SCHNELL, but in most cases dev works better. This is why I've selected dev in the workflows which you can download, and in most cases we will have a look at the dev results. The mask looks as expected. The SCHNELL result doesn't look very good, so let's have a look at the dev results. Regarding cherry picking, in this video for each test I will show you the results starting with the best ones, but I will tell you the complete number of images I have generated. And you will see examples of bad results too. So you can judge the quality of each workflow yourself. I've generated 21 firefly images with this workflow and obviously it does not work very good. We quickly drop the image with the second mask. The second test we will do with each workflow is more common, but here's another challenge. Inpainting glasses is easy when the face is completely turned towards the camera, but in this case we want to inpaint glasses on two faces at the same time and both are turned sideways to the camera. We changed the prompt to glasses, that's good enough. Again, the SCHNELL result is not very good, but later we will see another workflow which works quite good with SCHNELL. For dev, 4 results are not brilliant, but might be acceptable. In total I generated 30 images. Fortunately, we will see much better results with other workflows. The first improvement is setting a latent noise mask. This was already a successful approach with Stable Diffusion. By the way, you enter the Search Node dialog by double-click in the workspace. We have to add a node for VAE encoding because we won't use this special version for inpainting anymore. We connect the new nodes, and as soon as there are no more connections at the right side of the old node, we know it can be deleted safely. The latent image for the K-sampler now comes from the new Latent-Noise-Mask node. Again, the first test is the Firefly text, so we set the prompt and the mask accordingly. Let's directly look at the dev results. We have 4, I would call, interesting results, where at least the text is okay. I have generated 10 images, so it's better than the previous workflow, but still not good. 5 okay results for glasses. I have generated 31 images. The following inpainting workflow is the best one without using ControlNet. We add the new node Inpaint Model-Conditioning. We connect the new node. The Set Latent-Noise-Mask node and the VAE-Encode node are not required anymore. We get the first Firefly results with correct text and transparent background. I've generated 20 images and I'm sure this can be improved. I've generated 21 glasses images and 7 are okay or even good. Still, the number of bad images is far too high. In order to take some low-hanging fruits, I'll quickly show you an easy modification for outpainting. The prompt describes the complete scene and we do not draw a mask. The pet image for outpainting node is the only new node we require and it replaces the mask blur node. We have to set values for the number of pixels we want to outpaint. For all directions we set 128. SCHNELL doesn't work very well, but 2 of the 11 dev images are pretty good. Although I'm getting ahead of myself, I didn't get better outpainting results with ControlNet. Now it's time for ControlNet. First we add a load ControlNet model node. Select the Inpaint ControlNet Safe Tensors you have just downloaded. For this ControlNet we have to add a ControlNet Inpainting Alimama apply node. For a better overview we create a new group for the ControlNet. The positive and negative conditioning can already go into the K-sampler. As we require a latent image, we have to choose a different differential diffusion node. I haven't changed its parameter. Do you remember the Set Latent-Noise-Mask and VAE-Encode nodes from second workflow? We will use these nodes in this workflow too. Now we have to add the input connections to the Alimama apply node. One important hint regarding the parameters of this node. Start with a strength of 0.5 and change this parameter slowly. Set start and stop to 0 and 1. Don't change them in the very beginning in order to keep the complexity low. Yes, the ControlNet works with SCHNELL. It's not perfect, but it's faster than dev and great for trying prompts and parameters. I've generated 30 images with dev. Most of the time the text was correct and the background transparent. Nevertheless, quite often the background behind this transparency was not correct, if you know what I mean. Still, the ControlNet workflow shows the best results and this inpainting task was quite difficult. For comparison, here is a simpler task with a sine. So even this ControlNet Alpha version is good to use. The glasses inpainting works with SCHNELL, but you can definitely recognize that the ControlNet was trained for dev. Especially the skin tone does not match exactly. Dev works great with this ControlNet workflow. Most of the generated 37 images look okay or even good. There are just a few images with strongly visible bugs. I know that you're keen on adding LoRAs, so let's add one. We require just one additional node, load LoRA. Here I'm adding the Flux.1 dev LoRA with 8 steps. As unit model, we have to select Flux dev FP16, FP8 or Q80. The LoRA does not create good results with lower quantizations. And of course, the number of steps has to be 8. Important, you have to reduce the strength in order to get suitable results. I have set both strength values to 0.11. The result is okay, but at least during my tests not as good as using dev with 20 steps. For drafting I still prefer SCHNELL as it is faster than the workflow with dev and an 8-step LoRA. Both approaches are not perfect, so I would finalize the results with dev and 20 steps anyway. But try it yourself and share your experiences in the comments. So is the ControlNet workflow always the best one? It depends. If you have unlimited resources, then probably yes, but with limited VRAM, you might want to use Model-Conditioning Inpainting more often. You may need to generate more images than with ControlNet, but you can use smaller quantized models to save VRAM. Plus omitting ControlNet will save even more VRAM. That being said, I'm using the following runtime parameters for Flux and ControlNet. Standard workflows might get a bit slower, but they speed up the first image generation with new parameters. And don't forget, ControlNet Inpainting does work with smaller quantized models, but there's a noticeable difference in quality compared to FP16, FP8 and even Q80. By the way, the original image was generated using SCHNELL, without dev and LoRAs. If you enjoyed the video, please leave a like.